Hello, everybody. I am Federica Ciuffo. I'm a specialist solutions architect for containers at Amazon Web Services. And I'm here today with my colleague, Christian, from the Flexible Compute team. And we work a lot together with customers. And we see that one thing that comes on top of your mind, and now more than ever, are sustainability and financial goals, cost savings. So while moving your workloads to Amazon Web Services and the cloud, and adopting managed services like Amazon EKS certainly helps, this alone might not be enough to achieve your financial and sustainability goals. And for that reason, it's important that you also how you consume those services that we have as a cloud provider. In particular, it's important to reduce the waste on how you consume those services and to optimize then the resource usage of these services. So, in particular, at Amazon Web Services, we are on the path on using 100% of renewable energy within our data centers. And also, we really do care about how we consume and we deploy this infrastructure that you will be consuming with web services. But these alone is not enough. Again, you really need to have some architectural decision that optimize the resource consumption within your systems, with both sustainability and also cost savings in mind. For that reason, we understood here that, well, if you want to architect with sustainability in mind, you really need to optimize the resource consumption of these services. But here again, we are talking about Kubernetes. So how can we achieve these objectives if you are using Kubernetes on Amazon Web Services? And here I would like to make a distinction. So we all know that Kubernetes architecture we make this distinction between the control plane with the API server, etcd, etc., and the data plane. So if you are using Kubernetes on Amazon Web Services, it's most likely that you will be using Amazon EKS. And here a question, how many of you are using Amazon EKS right now? Well, a fair amount. OK. So if you're using Amazon EKS, actually, what is this? It's a managed service, a Kubernetes managed service. So basically, what do we manage? The control plane. We take the Kubernetes, we manage the control plane for you. That means that we deploy it in a highly available fashion across 3 availability zones. And also, we do take care of all the other things that most matter to you. Security and operational efficiency. In this sense, we also take care to optimize the resource consumption of the control plane in your stead, doing this heavy lifting so that you don't have to manage all these things in the control plane. And in particular, we also auto-scale the resources in the control plane. Think about API servers, etcd, etc. So this effort of auto-scaling this will optimize how you actually consume this service and will optimize how we as AWS offer Amazon EKS as a service to you, thus optimizing it for sustainability and costs as well. So what do you need to take care of when you are using Amazon EKS and you want to optimize for sustainability and cost optimization is the data plane, so where your pods are running. And, well, you can do this in many different ways, and Christian and I are talking a lot with customers, and we have identified some set of common questions that you usually ask, and they are actually very on point. So when thinking of data plane optimization, how many nodes do we need? Which is the right pool of nodes that I need? But not only how many nodes, which type of instances and size of instances is the most optimized for me? For example, In Amazon Web Services, we have created a lot of set of instances that really diversify the set of instances you can choose from, because we really want to have the right instance for the right workload for you. But this optimization effort resulted in 600 plus instances in Amazon Web Services, so it's a lot. And it becomes difficult to actually choose from this pool of instances, which is the right instance type for me is a very fair question, if you think about this number. So not only thinking about how many instances I want, which type of instance is the best one for me, how big should be my instance, but how can I do these decisions in an automatic way? How can I automatically autoscale my cluster and differentiate across the different kind of and set of instances that Amazon Web Services offers me? Other questions are, we have different type of purchase options. So you can choose between on-demand, spot, savings plans, which is the best suited for me. And then a lot of questions come around the technology ARM. So there are some changes that you need to do in your application to adopt this technology. So which are the real gains? Is it worth it? So we have the answers to these questions today. And we really want to go through the best practices that we see and that we have built with our customers when using Amazon EKS. And to do so, let's dive a little bit deeper into these questions. We can divide these into two sets of questions. One revolves around right-sizing my cluster, and the other is about diversifying the compute underlying the compute offer and among our worker nodes. So starting from right sizing, here we will be talking about nodes, right sizing, and right sizing the pool of nodes, the data plane. But if you think about it, always take a layered approach in right sizing. Kubernetes is not only about scaling the nodes, it's also about optimizing the application, scaling the application, if needed, increasing the density on the node to have more, to be able to schedule more pods on the same node. So many other different things. But what we have seen is that scaling the nodes optimally is a good point to start. And it's also where you can have more impact on sustainability and cost savings, as the compute part, in particular, is the one where you will be spending the most, for example. One of the autoscalers available that we have is Carpenter. And today we'll be focusing on Carpenter, not only because it's one autoscaler among the others, but because of its native flexibility, which is very important if you want to diversify, which is the other main theme that we reviewed in one of the very first slides. So what is Carpenter? Carpenter is a Kubernetes native autoscaler. We, as AWS, built it, but we open sourced it, so it's an open source project, and is application-centric. That means that the metric that it uses for scaling is dictated by the applications that are actually running on your nodes. Also, it's very customizable. One of the customizations that you can have is to use a custom AMIN within it, but it's very, very flexible, very, very customizable. In particular, it works very, very well with multiple types of instances working together, and not only multiple types of instances, but also multiple purchase options. You could be running on-demand and spot together, for example, and is compatible with ARM architecture. So this flexibility is why we choose to talk about Carpenter, and it's also why we are choosing with many of our customers are choosing Carpenter to autoscale their clusters. Let's review real quick how Carpenter works. So we said before that it is application-centric. What do I mean by application-centric? The metric used by Carpenter to autoscale is the aggregated requests of those pods that are marked as unschedulable by the kubescheduler. It looks at this metric to autoscale, but obviously it also looks at the constraints of the pods. Could be some labels on the pods, could be affinity, anti-affinity rules, node selectors, topology spread constraints, and others. After this, evaluating both the metric and the constraints, it will provision a node. And once the node is provisioned, it also automatically schedules the pod on that node. Not only it adds nodes, it also deletes nodes if needed. So if there is an empty node, it will be deleted. And if you have a node which is underutilized, then it will be consolidated. This is why Carpenter, in any point of time, it keeps your pool of nodes optimized always, and also it enables you to take advantage of mixing many types of, let's say, instance types, options, purchase option could be on demand, spot, etc. And this is what we will be seeing with Chris in our demo real well as well. This for the part of, let's say, right sizing. We also have another main theme, which is diversification. So how can I diversify, again, the pool of nodes that we have? And we had two questions. One was, how do I choose among on-demand, spot, and savings plans? Those are three purchase options that you have of Amazon EC2 instances. And actually, the right answer to this question would be, usually you use them together. And it will depend, obviously, on your application. But what we want to dive deeper here in this presentation is on the spot usage, because it's the one you can have most sustainability and cost optimization gains without any previous commitment. What it is spot? Spot, again, is a purchase option of Amazon EC2 instances. And it's not like we give you a host of worse quality or whatever. No, it's actually the same infrastructure of Amazon EC2 on demand. Simply is the surplus capacity that is not being used at any point in time. And for this, we want to optimize our utilization of our infrastructure by making this infrastructure that is there but is not being actively used available to you with a discount, which is very substantial. But there is a catch. So if on-demand needs this capacity back at any point of time, we will take it. So what it means for your clusters and your application. Your applications running on that node will suffer an interruption, but not everything is lost. Actually, we give you a 2-minute notice so that you can automatically wrap up your application nicely and move it, for example, if you're using Amazon EKS, to another node. And if you're using Carpenter, there are ways to automatically cordon and drain the node so that Carpenter will automatically move this application to a new node. So there are ways to automatize this, in particular if you're using Amazon EKS and Carpenter. And what it is important, if in case this interruption happens, is that you have a very big pool of nodes available for you to use. Because, yeah, we have a very big infrastructure in Amazon Web Services, but in particular, if you're using Amazon EC2 Spot, which is a surplus capacity, you need to be able to have this surplus available. So if you have more type of instances you can choose from, that probability is much higher. And this is why, again, Carpenter is a very good match with Amazon EC2 Spot, because it enables you to use many different types of instances together. About ARM, so is it worth to modify my applications? Well, let's review what it means actually for Amazon Web Services ARM, and which are the gains that you can have by adopting this architecture. First of all, our ARM instances in Amazon are called AWS Graviton, and the processor is custom built by Amazon Web Services, by us, to be super efficient. And I will explain what this means, but you can use it across many different workloads. Could be general purpose, could be storage optimized, compute optimized, memory optimized, etc. And what does it mean for you? So again, why should I adopt Graviton? We have seen that if you compare a Graviton instance with an x86 instance with comparable metrics, you usually have up to a 40% better price performance than the other instance. So what does this mean? When it comes to cost savings, you have up to a 20% less expensive instance. And for sustainability, you have up to 60% more energy efficiency with this instance. So it's better for the environment and also better for your wallet. And obviously, you can use Graviton with Amazon EKS. This is what it's all about. But when you're using an architecture, a product, whatever, with a service, you want to ensure that the support does not end there, and that whole ecosystem does support it. And in fact, Kubernetes in general has a terrific support for ARM technologies. And when it comes to AWS, we support it, for example, with Amazon ECR, which is our container registry, and with Carpenter. We already mentioned it a couple of times. And this is not an exhaustive list. Simply is a slide that represents that the support is there and it's very extensive. So just a quick recap. What we have seen is that for optimizing for sustainability and cost optimization means right-sizing and diversifying your compute pool of nodes. And we have used these technologies to do so. For here, up until now, is simply merely theory. But now I'm passing over to Christian Melendez, who will be showing you a demo to understand really the real flexibility of with Carpenter and these technologies.
All right. Thank you, Fede. Well, now I'm not going to be using any slides, any deck. I'm going to hand it over to the console, right, to show you how it looks like everything that we saw with Fede in action. So this is the project Carpenter SH. If you enter here, you can see the project basically explains what you just saw. And you can go here to the docs, and you can see where basically the docs are, some guides here, some how to get started here with an existing project, with an existing cluster, or with an existing from scratch, from a new cluster, right? I particularly have wrote these two tutorials, one that is basically guiding you step by step on how to create a cluster using spot instances with Carpenter. And recently, I built this project called Carpenter Blueprints, which is basically the foundation that I'm going to be using for the demo today. If you are getting started with Carpenter, if it's important that you go and go with the right direction, right? So basically here, what I guide you here is how to create a cluster using Terraform, using EKS blueprints. And if you go here to this folder in the main file, you're going to see here, basically, it's a Terraform template file, right? It's using the EKS module that it's already available there. So the idea is that you can see how it can converge, or you can still use some of the add-ons, in this case specifically, on how to, for example, how to configure Carpenter. You just simply say enable Carpenter and a few other settings here, and that's it. I'm highlighting this because what's happening here is that I'm not going to go through the process of installing Carpenter, because it might take some time to bootstrap the cluster and create the IAM permissions, the IAM role, and so on and so forth, right? So what I'm going to show you here exactly is I have 4 sections here. So I want to focus on the screen, perhaps not in me. So on the top, you're going to see a tool called Kubeops View. You can see here the representation of the cluster, which basically each box represents a node. Right now, I'm starting with 2 base nodes. It's going to be an on-demand EC2 node instances, and it's going to be a managed node group. On top, you can see here that are basically application pods itself. It's Kubeops View. And I have, for example, the Carpenter controller here, because we were, if you were here yesterday, we saw a session about how to create CRDs. And you now know that you need to have a controller, right? You know now the controller pattern. Basically, Carpenter is doing that. It's basically the controller that you have here, and it has 2 replicas. Below, you can see here the pod systems, kind of like the ones that are in the kube system namespace, and you can see that they are running. You're going to see why I'm showing this in a moment. I'm going to explain to you what our node claims here are in a moment, and here what I have is basically the logs of Carpenter, so that you can see what it's doing in action while I perform some stuff. Now, because I don't want you to see me type in, and I don't want this to be error-prone, what I've done here is basically automate the steps of the demo. So what I'm going to be doing now is to deploy a default node pool and an EC2 node class. I already showed you how to create a cluster, what is important, how to enable Carpenter, that when you use Carpenter, what you use is basically a controller. Now, the next step is, how do I get started, right? I need to have what is called a node pool and an EC2 node class. I'm going to show you here what it looks like in a moment. I'm just going to click enter here, and I'm going to create it. And I'm going to head over. You can see the logs that it's working here, right? I'm going to head over here to, you can see the YAML definition. Again, this is a CRD that Carpenter controller is reading, that it understands. And you can see here that it's basically the node pool. It's Carpenter B1 beta. Nothing out of normal here with that YAML file, right? So what you have here is basically the disruption. And this is pretty important, because what we were hearing before, that Carpenter, what it does is that it creates the capacity when you need it by scaling out, but it also does a very good job on scaling in. At some point, your pods, if they are come and go, your cluster is going to be ended up being fragmented, right? Like the memory fragmentation that you have. Same happens to the cluster. So what is going to be happening is that Carpenter is going to run simulations on each node, and it's going to say, like, what will happen if I evict all the pods from this node? Can I launch a new node that is going to be better, that is going to be smaller, or can I move around in the pods into other empty spaces from the cluster? That is basically what it's going to be doing. I'm going to show you that in a moment. So the way that you configure this is opt-in. This is not enabled by default, at least in this version. You basically say consolidation policy when underutilized. There are other parameters here. Again, this is just to give you a big overview of what the project is. Expire after, it means that it's going to take 28 days to expire the cluster. Why? Because sometimes for the security patches that you might need to have, the Carpenter can recycle that node and launch a new one with the latest AMI, with the security patches. Because remember, what we're thinking about right now is cattle, not pets, right? The node could be something else, and we're just focusing on the workloads. Now, let me guide you on this, right? Because this is pretty much what Fede was talking about. This is how you configure the node pool. The node pool is basically, what you have basically AWS, which is basically the universe of the cloud that you have there at the cluster, and you are limiting that universe of options, several options, purchase options, EC2 instance types, and you limit that on a node pool. You could use one node pool only to launch the capacity for all of the workloads, because again, what is happening is that Carpenter is doing the application first approach, right? So we're defining here that we're going to get started with, I only want on-demand instances, I only want x86 instances, and I want to diversify within these families, C, M, R, I, and D. Could be C5x large, C4x large, M5x large. Important note is that we have more than 700 instance types. I cannot even remember 30. So this is pretty useful because you can see here that I'm flexible, I'm open, and I'm going to explain to you why is this important. So, and you can say here, well, you know what, I'm flexible, but do not include me the first instance that you created in AWS. Do you know what instance type is that? No one? It's the one M1 M1 family. So you can say like, I don't want that family. I don't want to use that old instance generations because and so forth. My application won't support it. Okay, so now that's the universe of the compute. Now, if you're familiar with AWS, you're gonna see you're gonna think about like, yeah, what this looks like that auto-scaling group, right? We're no longer using auto-scaling groups. This is basically just a layer on top of EC2, the EC2 API. Now, the launch template, this is basically where you, this is not the launch template, but it's just to make something that you are familiar with. The EC2 node class is where you define, for example, the AMI family that you're going to be using, the role, the IAM role, and the subnet and the security groups. And of course, you can make it more complex here. You can use user data here to configure your nodes, install some stuff that you want here at the beginning, right? So at this moment in time, I'm going to leave it out there, and that's it. I have everything what I need, right? Now I'm going to deploy an application. It's basically deploying an application that is not doing something out of the extraordinary. You can see here that it's a deployment. It actually has replica 0. I did this on purpose, and using a pause image, because again, this is just a demo, right? I'm requesting one CPU and 512 megabytes of memory, and I'm using some topology spread constraints, because what I want to do is that this application to spread within availability zones. That's how you do it. Carpenter is not responsible of that. We are basically inverting the control of the application, right? If you are developers, maybe this resonates with you. So we are saying that from the application, I want to spread the pods within each availability zones, and the max queue, it's going to be 1. This means that for 10 pods that I have, I want you to spread them equally within 3 ACs. It's going to be 3, 3, 3. And the max queue, it's going to be 1. So that's going to be fun, right? So we can have 3, 3, and 4. All right, so I'm going to go here and do the replicas here. And what I wanted to see here is basically what is going to happen here. You can see here that pods are going to be pending here, because there's no capacity in the cluster. I forced it to make this happening, right? So there are pending pods, and this trigger Carpenter to get launch. And this is basically what I show you here, the node claims, because this is the concept. It's another object that Carpenter uses. It's the concept of a node claim that represents an EC2 instance of, or basically a compute worker node within the cluster, right? You can see here that they are spread within different availability zones, different instance types. One, actually, it's going to be using a C2x large, and that's it, right? And just in a matter of a few seconds, the application is running. All good, right? Now, that might give you some perspective of how we are using the cluster, right? You can see here that for each of these nodes, on the left hand here, you can see here there are 2 bars. That represents the CPU and memory of the node, and the colors that you see here, it's how much of that CPU and memory are being used. So far, you don't see something underutilized, right? I mean, it did the best it could. Now, we were talking about that it's not only about saving cost or that it's not only about sustainability, right? One step further for that is to make a better use of the utilization of the applications that we have. So imagine that I'm going to be running now here a stress test, and I notice that my applications are not actually using one vCPU and are not using that much memory. Let me show you this perspective, because what I want to show you here is basically something. I know that it's not related to cost, but this tool is called EKS Node Viewer, and you can see here how much it's gonna something that it's tentative, right? Per hour and per month. You can see here that right now 3 instances for 10 pods, it's gonna cost me 400 or almost $500. Keep that number in mind, please. Now, the first step, the next step, what I'm gonna be doing is basically to optimize the application. Again, I'm simulating that I just decided that I'm going to be using less resources here. Hope that you saw that you were able to catch that. You can see here that now the pods are using less CPU and less memory. Now we ended up with a problem, right? Because we over-provisioned the nodes before. Look what is going to happen right now. Because I have consolidation in place, what Carpenter is going to be doing here is basically disrupting via consolidation, delete. So it's going to say like, well, you know what? I can optimize this. And now I did a change because I wanted to optimize the deployment. I didn't want to spread within ACs, because this is, for example, a dev environment, and I don't want to spread them within ACs. I want to reduce the cost. So I reduce the number of CPUs and memory. It might stay the same, but look at this, right? Now it moved to 1 instance only. And of course, it's doing something here like, well, it's still underutilized. So it basically moved all the pods within to 1 node. But look at now, it's kicking out the consolidation again because, hey, you know what? I did a good job, but I'm going to continue improving that. So I'm going to continue improving that, and I'm going to launch a C6A X-Large, and boom, look at the cost now. Right, I'm using only 1 instance now. So let's continue on doing that. Now, the next step on optimizing for sustainability, and of course, this is impacted to the cost. Let's continue with doing something, right? Let's now move our application to Graviton instances. The only change that I'm going to do right now is to make or open the door to the provisioner to be able to use Graviton instances, and I just applied that. You're going to see the logs here because it's actually happening live, right? Let me show you what I did with the provision, with the node pool, sorry. We just moved to Carpenter V1, and we changed from provisioner to node pool. So if you hear me here saying provisioner and node pool, it's the same, right? Sorry about that. So the node pool here, you can see here that it's 86 and ARM64 flexible now. The architecture can use both. Now, what is going to happen here? You can see here that it's going to be, again, consolidation is going to kick in. Why? Because it's going to run a simulation of evicting these pods here. And what it's going to do is that it's going to call the EC2 API. And the EC2 API is going to say, like, you know what? There's a better price for a similar instance, but it's on Graviton. You can see the difference here in pricing, right? It's cheaper. But we said that it's going to be 40% price performance because at the end, it's going to be cheaper, but you're going to end up using, most likely, less number of instances. Again, that's tied to not just to sustainability because we're better making a better use of the energy that we're using, but we are actually helping you to use less nodes. Look at this. It reduced the bill a little bit, but again, that was not the whole purpose, right? Now, one step further we want to take is with Spot. When I was doing this, let me kick in this because I'm going to do something similar. With the provisioner, now it's flexible, on-demand, and Spot. What is going to happen here? Because one of the main mantras or the principle of Carpenter is to make a better use of or launch the right node at the cheapest price possible. What is the cheapest model? Spot. Okay? You saw that we can get up to 90% performance compared to on-demand. That's because it's spare capacity, right? On average, what we see right now, if customers that are being well diversified, is that they can, on average, 60% discount off. I'm going to show you what it's going to look like right now. Because, again, consolidation is going to kick in. The same process that I just explained to you before, it's going to happen. What I haven't told you so far is that what is happening under the hood here. You can see here that is spot instance, and the price, wow. It went down, right? You're going to see this in a moment. $46 spot. Let me explain to you a few things here. What is going to happen with Carpenter is basically going to call the EC2 API, and if it's an on-demand instance, from all the instance types that it's going to be able to choose, I'm going to show you that in a moment, it's going to pick the cheapest one on demand. If it's for spot, it's going to choose the cheapest one that has more spare capacity. That's what we call the price capacity optimized strategy. But that's the intelligence behind it is in the EC2 API. It's not in Carpenter. Carpenter is just calling the EC2 API, and the EC2 API is doing its magic, right? So it's going to launch that. Now, let me show you here this, because what I want to show you here, and I'm going to be pretty close to the end here. You're going to see here, node claim, it didn't. Node claims. That's it. Let me show you this. You can see here the definition of the object here, the CRD, that is flexible on these families. But look at this. These are all the instance types that I can choose from, and the EC2 API is going to choose the cheapest one that has more spare capacity. Why is that important? Because if I had more spare capacity, chances are that I'm going to end up interrupting your instance the less. Okay? All right. So to put this into an end, what I'm going to do is to mix everything, right? You can have a mix and match. What we were saying before is that you don't only have to focus on Graviton. You don't have to focus only on Spot. You can also do a mix and match. So what I'm going to do here is basically go to replica 0, because I want to clean the environment. And you can see here that pretty rapidly, it's going to remove the node, because I have no more pending pods here. I have no pods running here. The only ones that I have here are basically some daemon sets for the application. Boom, the node is gone. Now, what I want to do here is to mix and match here, and I'm going to apply this. And you're going to see in a moment that this is basically going to apply now some strategies that I'm going to explain to you here. And I'm going to deploy the application now. OK. I'm going to leave it here. And basically, what I did is that I created another node pool. You see here that I had this one, right? The default one that is using on-demand, but I added a new label here, capacity spread. And I added some weight here, 1. For Spot, what I did is it's basically the same node pool or the same definition, but what I did is that I added another capacity spread, and I added some other weights. What I'm trying to do here is that, for this application, it's Black Friday, it's coming, and I want to at least reserve some capacity, and I want to split that. And I want to take the most of Spot, and I'm going to go 80% on Spot and 20% on-demand. All that magic. The application, you're going to see here basically that now it's requesting 30 pods, and nothing changed too much. You already saw that the topology spread constraints, this is now production, right? We want to have it back. And for the other topology spread constraint, it's going to be the capacity spread. And this is how you kind of like apply the trick of having a split between on-demand and Spot. All right, and you can see here that it's doing this, and it's going to be launching the pods here. But let me show you this perspective here. You can see here a mix of a Spot on-demand, and this is the beauty of it, right? Different instance types, different sizes, different architectures, different availability zones. Why I'm doing this? Because if I get a spot interruption of, for example, this pool, chances are that the other ones are not going to be affected. So you basically reduce the blast radius of receiving that interruption. And I wanted you to keep this, all right, of course, this number increased, right, because we increased the replicas. But we might not have time to look at this at the end. But I want you to notice, if you've been paying attention, what has been happening constantly is that Carpenter has been consolidating these pods. Again, this is something that you can enable or disable at some point of time, right? It's going to be consolidating the pods. It's going to be removing, replacing. It's going to be moving them. So at some point, you may end up with 2 less nodes. I'm not going to wait for this because time restriction, right? So this is it. This is what I wanted to show you here. And if you want to go ahead, and you might be wondering, well, what else can Carpenter do? I have you. With these Carpenter blueprints, if you go to the end, you're going to see here, like, what else can I do? I can go with high availability spread pods across ACs, what I just saw you, split on-demand and spot instances, what I just showed you here as well, prioritize saving plans or reserve instances. So use that capacity first, and then you scale out with spot. You can use that. And I mean, we're going to continue adding more patterns here, more blueprints here as we progress the project. So look at this project, because this is your ultimate guide for best practices and how to get started with Carpenter, right? And that's it. That's with everything that we showed to you before, Carpenter, Graviton, Spot, and Graviton. This is how we are saving the planet one pod at a time. Thank you.
Thanks. Thank you for this talk. There are a lot of questions, but they are mostly related to the same topics. And some of them we already discussed in the backstage. So let's see. I know AWS is very protective about many things, but let's see what you can tell us. And if you cannot say it, just say, we are not allowed to disclose these things, OK? Well, one of the main things is basically, OK, what about Carpenter? Sorry, can you keep it low, please? You know, how production ready is Carpenter? In terms of, like, of course, we keep adding new functionality, so chances are that the API of the CRDs might change, even if it's slightly. And then if you can talk a bit about what are the plans for making this available on more places than, let's say, EKS, which we discussed a bit. If you can talk a bit, because I don't know if you were telling me privately or, like, you know.
No. All right, so Carpenter was launched on November 2021. And since we launched it, it's GA. It's production ready. Since then, it's been 2 years now. It's been used by several customers. We have tons of use cases right now, some public use case studies, some public references. I hear customers saving 80% of their EC2 bill monthly. We actually did a presentation with Fede on the summit this year with a customer that were able to save 70% off on EC2. By mixing all of this, right? And regarding the question of changing the CRD, this is the only time, a few weeks ago when we graduated the project to a beta, this is the only time that we have changed the CRDs. Again, because we are in the process of making this stable. You know the process of making tools stable in the Kubernetes ecosystem. It goes with alpha first, then it goes to beta, and then when it reaches some maturity here, it's going to go to stable. So this is the only time that we have changed the CRDs, but with that in mind, with the focus on keeping that stable for B1. Do you want to take the other question about what we discussed?
So it's mostly making Carpenter compatible with, say, Azure, potentially even Google Cloud, or even there are a lot of people asking if there are any plans of making it, you know, available for things like that run on bare metal, or even VMware offerings, VMware vSphere, all these sort of like plugins that potentially could exist at some point.
We are on that path. Actually, I think two days ago or something like this, we just launched support for EKS, which is the Kubernetes management service on Azure. And actually, Carpenter is an open source project. So if you want to let's say, contribute to it, happy to do so. And but that's the plan. The idea of having this project open source is to make it compatible to as many platforms as we can. We started with Azure. Yeah.
Yeah, and in addition to that, we split the project. That is called Carpenter Core and Carpenter AWS. We are in the process of finishing up, basically donating the part of Carpenter Core to the CNCF. 2 weeks ago, 3 weeks ago, something like that, we actually opened the space for the community to provide feedback. If someone was against of it, or if someone wants to add something, it was open. If you are in that ecosystem, you might have heard about it. That time period has closed now, and now it's in the process of making the process an incubating project of the CNCF. It could take some time, right? But that's it. The Carpenter Core has been donated, and as we did with AWS, and as Azure has done with Azure, we foresee that more cloud providers, bare metal, Red Hat, or anyone interested in contributing, it's going to launch its flavor, right?
And yeah, we're running out of time, but there was one that it's something that I'm curious about. Like, you know, Carpenter computes like if you need more capacity or there's spare capacity. What happens does it take into account things like cron jobs that you may not want to be interrupted?
Yeah.
Okay.
Yeah.
If the answer is yes.
Yeah, so you can basically add a label to those pods, or to the pod manifest, to do not evict the pod. And when the consolidation kicks in, those pods are going to get ignored and are going to stay there. So for those, basically, when the node is empty, as you saw here in the demo, the node is going to disappear. So yes, you can do that.
Okay, so yeah, we ran out of time. Sorry, folks, but I guess you will be around, hopefully,
Yeah,
or you're running back to Madrid. Okay. Okay, so see you after lunch, folks. Thank you, everybody.
Thank you.
Thank you.